Lab 5, Vertical Acceleration in Relation to Horizontal Movement, Richard Moore. Instructions. The instructions for Lab 5 were to determine your own experiment. For my lab, two objects are to be dropped, one being dropped vertically and the other having a horizontal component in addition to being dropped vertically. The motion of such objects are to be analyzed, notably including the time of landing. The experimental motion is to be compared to a coding model to which conclusions are to be drawn. Instruction purpose. The purpose of this lab is to prove that horizontal velocity and acceleration has no impact on the rate at which identical objects are falling. Overall, this relates to a larger purpose of understanding the physics principles behind the concept of free-fall motion and vector motion. Results preview. Through this lab, the motion of a falling object with horizontal velocity versus no horizontal velocity was evaluated. It was determined that the horizontal component of velocity does not have any impact upon the time that an object takes to fall, given that the initial vertical velocity was 0 meters per second. The models and principles used in this lab were Newton's second law, Fg is equal to mg, the position update formula, and the velocity update formula. Principles rationale. Newton's second law was used in order to promote the addition of forces. Fg equals mg was used in order to find the net force in the y direction acting on the object, as this was the force of gravity only. The velocity update formula was used to find the velocity of objects in the system, and the position update formula uses the velocity from the velocity update formula to find the position of the objects in the system, including what vertical height it is at. The systems and surroundings for this lab. The system was the two hockey pucks being dropped, which were the objects that I dropped, and the surroundings was everything else in the frame of the video and experiment, including objects such as the background. So the initial conditions for this lab were that the hockey pucks weigh the same amount, they are identical, at 0.16 kilograms. Both hockey pucks are dropped from the same vertical height. The second hockey puck dropped is to be given a horizontal velocity in addition to being dropped vertically, and air resistance can be interpreted as negligible, as the hockey pucks are very small. Here's my video.
3, 2, 1.
From that video, using Tracker, these two graphs were created. The left graph is for puck A, which is just dropped vertically, and the right graph is for puck B, which in addition to being dropped vertically, was also given a horizontal velocity, as seen in the video. The second aspect of this lab was coding. Using coding on GlowScript, I was able to find these graphs presented here. On the left in green is puck A, or puck 1, which is only dropped vertically, whereas on the right in the red is puck 2, which is both dropped vertically and given a horizontal velocity. From these graphs, in both the experiment and coding, it was found that the puck A experimental time of freefall was 0.567 seconds. The puck B experimental time of freefall was 0.533 seconds. Puck A coding time of freefall was 0.48 seconds, and puck B freefall in coding was 0.48 seconds. From this analysis, it can be concluded that having a horizontal velocity does not affect the time it takes for two identical objects to fall if dropped at the same time from the same height, as puck A and puck B experimental had roughly the same time of freefall, and puck A, puck B coding had the same time of freefall as well. The potential errors in this experiment. So the first potential error in this experiment was that the hockey puck was not thrown perfectly horizontal, rather having an element of vertical motion besides freefall. And the second potential error was that the two hockey pucks were not thrown at the exact same time, and the preciseness of the video frames was not able to account for such a difference, leading to disparities in time of freefall. What if one hockey puck is dropped with the flat side facing down, while the other hockey puck is dropped on its side? Will they still land at the same time, or will air resistance have a significant effect? The answer to this question is the hockey pucks will still land at the same time since their vertical velocity and acceleration is the same. The effects of air resistance are still negligible as they are not big enough to have an actual impact upon the scenario. Here's evidence for such a solution.
3, 2, 1.
And then in regards to this what does it mean question, if the hockey pucks hit at the different times, despite being dropped at the same time, from the same height. Under this scenario, the hockey pucks would have to be different weights as this is the only thing that would significantly impact the force of gravity, which is directly affecting the time it takes for the hockey puck to fall. In conclusion, overall, the motion of a hockey puck in free fall was analyzed, one with no horizontal velocity and one with horizontal velocity. Having a horizontal velocity does not impact the time it takes for the object to reach the ground. And finally, only vertical force, velocity, and acceleration impact this time value. Thank you.